Hey, what's going on, guys? Coming again here. Last video we ended up completing our hex editor, so from now on we can enter whatever bytes to literally whatever location, by the way, even though only the specific range is assumed to be used for creating actually coding in x86 machine codes, and this space is here, so-called hex editor's source file. This is the chunk of up to 512 bytes, starting from address 500's hexadecimal and to this one. All right, so just a quick recap from the previous part. So we go edit, and let's say I want to put the byte right over in here. I can say 0500 and add a single byte, and that's pretty much it. Okay, but here is the deal. So let's assume that it's not just random bytes, but some sort of bytes that we've entered, like some sort of x86 machine codes. For instance, like, so we just probably, oh my god, did I just delete those? Yeah, apparently I have deleted. Okay, I just made some cleanups. Okay, so in this case, let's just create a new file. Yeah, and let's call it hello.asm. All right, so here, well, in order to avoid relying on the data segment, in order to avoid relying on like segments, so no variables would it be, I just want to draft a few lines. So here we go. So I need to say move ah0x0e, and here I want to, so this is the BIOS code to output single character, to output a character. Okay, and move al, and then what characters? So let's say h. So here we have the chart to print, and then int 10, int hexadecimal 10, and here we want to print the character to screen. Okay, now well, we can start with this sort of a thing, and that would be literally enough. So if I just say, yeah, let's close the app. So if I say nasm -fbin hello.asm -o hello.bin, and then have a look at the hello.bin bytes. Excuse me, what's wrong there? Oh, it didn't, sorry, just didn't save it. Okay, so here we have 1 2 3 4 6 7 8 9 sorry, 1 2 3 4 6 1 2 3 4 5 6 6 bytes. So here we have 6 bytes, okay, to print this H character on screen. Okay, and let's say, just to return back to the shell, we can say jump hexadecimal 800ths. This is the segment, and the offset is 0. So here, go back to shell, we'll return to shell, and let's, so here, yeah, we have another couple of bytes. So if we now run this code, if we now put this code to the certain location in the random access memory and try to run this code, it would print H on screen and go back to shell. And if we use our I want to run, yeah, so let's say I want to use my hex editor to input this kind of bytes. All right, so yeah, just to see the bytes. So here I can say So 0500 B40E, B048, CD10, and then EA0, 0, 0000, and 08. And I have these bytes here. So if I only could put the instruction pointer to this, pointing to this exact very first byte here, and this would automatically run the program. But how can we do that? And here's why we need the run command, which is the topic of this tutorial. So now we need to create a command that would be allowing us to type run, and we just don't have it currently, and it would then jump to this exact location, okay, and actually run whatever code we have there. Okay, so that's the idea. So without further ado, let's actually implement that. Okay, so I'm gonna be overriding the games further on because yeah, still lots of things, lots of system utilities that I would like to add here. So instead of the Tetris, we will create the run command here, save, and here in files, here I want to have the run command 1 2 3 4 5 6 7 8. Okay, so every file name should be exactly 8 bytes long, so the offset the offsets are matching because the offset is 8 bytes, okay, for a file name. All right, and now let's go to the run shell. So here, instead of Tetris, let's concatenate this run.bin, and here I want to say nasm-f bin run.asm-o run.bin. So we've assembled the run command, okay, then we do put it, that we concatenate it, okay, and we change the file name, so we should be able to run it, okay. And also in the memory map we did make an update. So now here I want to make a new file, let's call it run.asm, and I just want to bring in some boilerplate code from, let's take it from list command. Yeah, and by the way, something else to consider. So yeah, bootloader. Yeah, let me just close all of them. I just want to make sure that all the headers match. Edit. Okay, so this is run. So here we want to have the Hex Editor. It's not the list command. So this is the Hex Editor. Save. Files. Files is okay. Hello ASM doesn't matter. And run ASM, yeah, let's just take the list ASM and bring it all here, save, and this is what it's gonna be the run command. Okay, so we need the shell segment. So oh no, hold on a sec, we don't need the shell segment. No, we'll define a separate segment there. So we need to, yeah, we actually need to define so how on earth I call it, Hex Editor source file, let's call it exe file segment. Well, actually, it's the command file. It's not execute. It's like if we talk from the MS-DOS terms perspective, it's would it be better to call it command file segment, and the segment itself is gonna be 0x50 like this, because of the formula on how to calculate the address Oh my god, I probably have it in the boot sector. Yes, if we're interested how this is obtained, so we just multiply by hexadecimal 10 and we get the actual address. Okay, so to get this address, so this is the segment, okay, but we need the address of 0/500, so we need to say 550 by hexadecimal 10, which would result in 0/500. Okay, so this is the executable file bytes typed from Hex Editor. Okay, yeah, that's pretty much it. Okay, yeah, so all the stack stuff remains the same. Here I want to jump to the command file segment, so command file segment. So here we want to execute code at 0x0000500. Okay. All right, so we don't want to print the files. We don't even need to print the string, but definitely not to read the sector. We don't need any variables, right? So it's very simple, very simple thing. So we just need to jump there and that's it. Okay, we just need to jump there. Okay, yeah, okay, yeah, I think this is it. Yeah, let's try to test it. So if I now type run, it should just stuck forever. Oh my god, no, it's because file address undefined. What? Oh, whoa. Oh, that's the code for initializers for uploading the yeah, we don't need that. Okay, so if now I type run, it should stuck forever because there is no code at this 500s. Okay, but if we now type there something like the bytes that we had previously, so let's say xxd hello.bin, right? So these are the bytes. Now we run. Okay, so what I want to do now, I want to type in the bytes again. All right, these bytes. So let's go to the editor and 0500 B40E B048 CD10 EA 00000008. Okay, so we got our bytes just right in there. Now let's go back to shelf. Now type run. It should print the H. It should print hello ASM. Oh, cancel. It should type H and then go back to shell. It's not even going to be printing a new line, so the shell symbol should be just right after the H letter. And this is exactly what we have, guys. So you see, like, this program that we've just written into the random access memory has been executed. So it's not very impressive, I know, but that's kind of how it works, and we can run it no matter how many times. it would still be executing the same thing, because then it just returns to shell. So now let's complicate the code a little bit just to type the entire hello world, the entire hello word. The hello world would just take ages to type in this manner, but this is just a proof of concept stuff. Okay, and then print the new line in the end. So let's go for it. So I just want to like copy paste this a couple of times. So here we will have like this, like this, like this, and the new line and the carriage return, and that's it. And then go back to shell. So I want to now, I assemble this again. So now we have more bytes here, okay? And now let's run our operating system. Okay. So we need to type all these bytes in. So let's say edit and 0500. I will now show you how we can input line by line, for instance. So B40E, B048, CD 10. I made a space, but it doesn't matter. It would still be, it would still print them properly. Okay, B40, and here I missed the space, but that's okay as well. So B40E, B065, CD10. Well, I guess CD10 means like interrupt 10, 10H, CD10. So I'm here now. B40E, B06C, and I hit enter. So we have exactly the half of the line. Now to start typing from the next half of the line, I need to say 0510, okay, because 10 in hexadecimal is 16 in decimal, so we just skip the first 16 bytes and starting from the 17th byte. So first one would go here, and type the bytes in CD10 B40E, okay, B06C, CD10 B40E, B40E, B06F, CD10, and B40E. And now it should match the end of the line. So let's have a look, and it does exactly matches the end of the line. So 2 lines here is 1 line here. Hope that's clear. And now the very last line, so starting from 0520, starting from here. So B00A, CD10, B40E, B00D, CD10, EA00, 4 zeros, 08. And here we go. So this is it. And now we just go back, and if I now type run, it should print hello new line and return to the shell. And this is what it does basically, guys. This is it. So it just prints hello and returns back, which means that from now on we have an absolutely standalone development environment for our GameOS. So we can now write apps and games in machine codes using this Hex Editor and then execute them. That's pretty it. That's pretty much it. Okay, so this is regarding this tutorial, and the next absolutely essential thing to consider. So you might be wondering, well, okay, so I did type the program in, I can run the program, but how about saving the program? So the next thing we're going to implement is the save command that would have been taken 512 bytes chunk from the memory, from the random access memory, starting from address 500 hexadecimal, and then storing this to the floppy image, which is written on the USB flash drive. So the next step, we need to store these bytes. Store all of these bytes representing our program to the storage device. So in order to, next time when we run the operating system, so if we just after save, we want to type list, and here a new file should appear, and we need to be able to run that file, right? We need to be able to run that file just like we can run whatever other file here. Okay, so that's pretty much it, what I wanted to say, and that's the next step. So yeah, this is it. Thanks for watching, guys. Hope you learned something interesting out of this tutorial. Until the next time, and take care.